Let's jump right in. Every single day, you send millions of microscopic heroes on this epic, totally invisible journey across the globe. Seriously, whether it's just a quick text, a hilarious meme, or that super important work email, that simple piece of data goes on a wild quest through the hidden layers of the digital world. And in this explainer, we're going to trace that exact journey.
You double tap a photo, you hit send on a comment, and boom, it's just there. It kind of feels like magic, right? But how does a message actually cross the internet? Well, we're taking a look right behind the scenes of your daily digital life, pulling back the curtain on the actual mechanics of cyberspace. To get how it all works, we've got to look at the master blueprint that literally makes the whole internet possible. Okay, let's dive into this. Meet the OSI model, or the Open Systems Interconnection model. You can think of this as the ultimate rulebook for the internet. It's basically a conceptual framework that networking engineers use to standardize how completely different systems talk to each other. Because, without this framework, an Apple device wouldn't have a clue how to talk to a Windows server, and the internet as we know it simply wouldn't exist.
Moving right along to Section 1, the Hidden Internet Framework. So, to reveal the invisible structure that guides your data, the magic number here is 7. The OSI model actually divides networking into 7 distinct layers of responsibility. Think of it like a highly complex, ultra-efficient global postal service. When you write a physical letter, you don't just, throw it out the window and hope it gets there. It goes into an envelope, then the mailbox, the local post office, a shipping plane, and finally to a mail carrier. Well, these 7 layers operate exactly the same way for your digital data, stepping all the way down from your screen to the physical cables and then back up again. Let's see how this starts in Section 2, Formatting the Message. Let's move to and see how this builds. Our data protagonist is starting its journey right beneath your fingertips. Up at Layer 7, the application layer, you're interacting directly with a network. Think of your web browsers using HTTP or your email apps using SMTP. The second you hit send, your data drops down to Layer 6, the presentation layer. Here, your data gets formatted, encrypted for security, and compressed. And then it drops to Layer 5, the session layer, which establishes, maintains, and ultimately terminates the communication session, making sure everything is perfectly synced up. Now, what's absolutely crucial here is the massive importance of that presentation layer. Its main job is to ensure that data sent from one system is completely readable by another. It's acting like a universal translator for our package. Because of Layer 6, it doesn't matter if you're sending a message from a smartphone to a smart fridge or a laptop to a massive data center. Character encoding and secure data transmission are handled right here, so your package arrives perfectly readable. Next up is Section 3, Transport and Routing. And this brilliantly illustrates what happens next. With our message all formatted, it's time to actually move it at Layer 4, the transport layer. This layer manages segmentation, error detection, and flow control, and it basically has 2 main shipping methods to choose from. On one side, we have TCP, which gives you highly reliable data transfer. It checks for errors and makes sure every single piece arrives. It's like sending certified mail where you need a return receipt. On the flip side is UDP, which is built for pure, unadulterated speed, but is, a bit less reliable. So if you're sending a text message where every letter matters, you're using TCP. But if you're live streaming a video and can afford to drop a pixel or 2 to keep things fast, you use UDP. All right, once the shipping method is locked in, the package drops down to Layer 3, the network layer. This is the realm of the Internet Protocol, or IP. This layer handles logical addressing and routing. So think of Layer 3 as slapping the ultimate digital zip code right onto your package. It analyzes the entire global network to figure out the absolute best, most efficient path for your data to travel across the world.
And now we're diving into Section 4, the final delivery.
Accelerating down into the actual physical machinery of the internet, the package hits Layer 2, the data link layer. Now, while Layer 3 was focused on that global zip code, Layer 2 acts way more like the local delivery truck. It's responsible for node-to-node data transfer. It organizes your data into smaller chunks, called frames, checks them for errors one last time, and uses MAC addressing to physically hop from your computer to your router, and then your router to the next switch.
And finally, we hit rock bottom, but in the best way possible. Layer 1, the physical layer. Here, our digital message, which started as just a photo or a text on your screen, transforms into pure physical energy. This layer deals with the actual transmission of data over hardware. It dictates the cables, the switches, the data rates, and the actual voltage levels. Your message literally becomes pulses of electricity or flashes of light shooting through fiber optic cables buried deep under the ocean. How wild is that?
Bringing it all together in Section 5, Why this model matters.
So, the crucial point is, why do IT professionals still rely on this abstract framework? Well, our message flies across that physical layer, then climbs right back up layers 1 through 7 on the recipient's device. It's an incredible journey, and this model gives us 4 massive advantages. First, it provides a standardization of concepts, basically a common language. Second, it makes troubleshooting way easier. You can isolate problems by layer instead of just guessing. Third, it guarantees interoperability between completely different vendors. And fourth, modular engineering design, meaning, hey, you can upgrade those physical cables at layer 1 without having to rewrite all your software up at layer 7.
It is absolutely astonishing what happens in the mere milliseconds after you press a button on your phone. Next time you hit send, I want you to think about that invisible 7-layer journey happening right under your fingertips. Your data gets translated, encrypted, addressed, chopped up, and fired as electricity across the globe, only to be seamlessly reassembled on the other side. It really makes you wonder, what else is hiding in the cables? Thanks so much for joining me on this explainer. Keep asking questions, and I'll catch you next time.